Good afternoon. My name is Kira Proctor and I'm the Managing Director here at the Proctor Group. I'm going to be talking you through our webinar today, Membranes Explained, which will be followed by a question answer session with our Technical Director, Ian Fairnington. So please feel free to type any questions you may have along the way, and Ian will be able to answer these at the end of the session. Lastly, please bear in mind that when we're talking about these membranes and the placement of the membranes, we're discussing them within the UK climate, or certainly climates which are heated rather than cooled. The first thing to consider is that construction membranes perform a variety of important functions within the building envelope. These membranes are a relatively recent addition to building design. However, the pace of technological improvement and the rate of adoption of such membranes is arguably faster than any other construction technology. With performance requirements of both the membrane and the building on which they are used improving all the time, it's absolutely crucial to ensure correct materials are specified. Okay, so BS 5250 is the code of practice for the control of condensation in buildings. What this does, it outlines where and when the membrane should be used, along with the ventilation requirements that may apply. BS 5250 actually defines the various types of condensation control membranes. Airtight layer, a layer which prevents the convective movement of air under the normal pressure differences found in buildings and which may also act as a vapor control layer. Breather membrane, membrane with a vapor resistance of less than or equal to 0.6 meganewton seconds per gram. Type ACHAir underlay, also known as a high resistance underlay. Underlay which has a vapor resistance greater than 0.25 meganewton seconds per gram. Type LR underlay, or low resistance underlay. Underlay which has a water vapor resistance less than or equal to 0.25 meganewton seconds per gram. Vapor control layers, material of construction that substantially reduces the water vapor transfer through any building element in which it is incorporated by limiting both vapor diffusion and air movement. So the industry has a responsibility to ensure these membranes are not only up to the required specification, but that they're used in the correct position within the building. By ensuring they're in the correct position, you can ensure that they're performing the functions that they've been designed for. Breathable membranes are installed on the outside of the insulated envelope, and what this does is allows the membrane to provide temporary weather protection during the construction, and then secondary protection once the building is actually complete. These membranes generally contain something called hydrophobic additives. Now, basically what that means is that they're actively repelling liquid water. The vapor permeable nature of the breathable membranes, they actually ensure that any moisture that's within the construction or that originates within the building, so that could be the building use or occupants, allows it to escape through the atmosphere as easily as possible. Insulation prevents heat loss from the building envelope. However, if the specification has not been carefully considered, so for example, it's not thick enough or it's not been placed in the correct location, this could lead to moisture vapor getting trapped in cold areas, and that then can lead to condensation. A vapor control layer is installed internally, and what it does is help prevent any condensation or moisture vapor actually entering the roof or wall construction. So in addition to ensuring these membranes are in the correct position and you're comfortable with that, it's very important not to forget that they also need to have the correct technical performance. In terms of composition, breathable membranes are typically engineered plastics, known as polypropylene or polyethylene. I covered briefly the definitions under BS 5250 a little bit earlier, and what BS 5250 defined was that a breathable membrane requires to have a vapor resistance below 0.6 meganewton seconds per gram. However, it's important to remember that for roof applications, it has to be 0.25 meganewton seconds per gram or lower. Once you're taking a breathable membrane to be used in a roofing application, what you'll hear is the terminology change slightly, and they are generally referred to as a Vapour Permeable underlay, or a VPU. Roofing breathable membranes or Vapour Permeable underlays can be airtight or air open, and what that will have an effect on is certainly the amount of ventilation, or if ventilation is required on that particular roof. So in the UK, these membranes are always used on the cold side of the insulated envelope, so meaning it's always on the external side of the insulation product. Vapor control layers are generally made of polyethylene. Now that could be unreinforced or reinforced depending on the application. If a much higher performance is required, it can be supplemented with a layer of aluminium, which gives it a much higher vapor resistance. The performance required from these vapor control layers is much more closely linked to the building usage than the case for breather membranes. So essentially, dependent on how much vapor is going to be generated within a particular dwelling or a building will dictate the performance that the vapor control layer requires to have. For example, low-risk applications which are less humid, so perhaps a warehouse or an industrial unit, they'll typically use VCLs with a resistance of around 125 to 250 meganewton seconds per gram. But then you'll have a higher risk application, perhaps a swimming pool, and they will incorporate the aluminium foil like I spoke about earlier, and they might require resistances as high as 44,000 meganewton seconds per gram. And vapor control layers, being the complete opposite to breathable membranes, are always installed on the warm side of the heated envelope, therefore on the inside as to where your insulation's been placed. So while there's a degree of overlap in the functions of the various types of these membranes, the differences between them are significant, and this of course is going to have an effect on how they're being used. The composition of an air permeable membrane is a core layer of melt-blown polypropylene, which is sandwiched between two layers of spun-bond polypropylene. It's these outer layers that help provide additional water resistance, and it also protects the core from physical damage. It might be hard to picture, but the actual fibres in the melt-blown core are hundreds of times smaller than a human hair. And what this does is gives the membrane a microporous structure, which means that it allows water to pass through as vapour, but not as liquid. So the open nature of air permeable membranes therefore allows air movement through the membrane, and that in turn boosts the rate at which vapour can escape a roof. And what that does is significantly reduces the risk of condensation occurring in the roof. Film laminate membranes, instead of using a melt-blown core, they use a film core in the centre of the product. Similarly to air permeable membranes, the film in the centre is sandwiched between two carrier layers. And as before, what these outer layers do is provide additional water resistance, and they protect the core from any damage. The water holdout properties of this film core generally mean that these membranes are typically offering higher levels of water resistance than the air permeable materials. However, that does come at the expense of a greatly reduced vapour permeability. The good news is, in comparison to the breathable membranes, vapour control layers are relatively simple. Most vapor control layers are polyethylene or aluminium, and none of them have perforations. And what that does is ensures that the vapor resistance and airtightness of the product is maximised. When it comes to vapor control layers, reinforced membranes are generally preferable. So basically, the performance of the membrane is only as good as its continuity. Unreinforced membranes can tear and stretch unless care is taken during installation. This diagram shows a traditional type of roof construction, which is using a type ACHAir underlay, as I defined earlier in BS 5250. So this type of underlay includes a traditional bitumen roofing felt, as well as a more modern plastic equivalent. Due to the nature of the type ACHAir underlay, it means that vapour can't escape through the membrane at all. Therefore, it has to be removed from the roof by means of ventilation openings. So the exact specification of the ventilation may vary, but typically vent openings are provided at the eaves of the roof and then again at the ridge. Whilst this method is effective and it's been proven over a long period of time, the roof is actually susceptible to vents becoming blocked. So for example, items could be stored in the loft. And certainly for more complex roof configurations, you must ensure that there's adequate airflow throughout, and that can be quite challenging. So coming on to airtight LR underlays or low resistance underlays, they can improve the situation by essentially allowing the vapour to escape through the entire roof surface and not just through the ventilation openings. So whilst this reduces the likelihood of the vents becoming blocked, airtight LR underlays do not have sufficient vapour permeability to eliminate the need to ventilate altogether. Now that's particularly true during the initial phase after construction. And at this point, there's a significantly higher moisture load from wet trades, etc. And this is known as the drying out period. It's therefore very common to see airtight LR underlays requiring 5 millimeters of ridge ventilation, and that assists in the removal of vapour. They also usually require the ceiling to be very well sealed, or certainly a vapour control layer to be used at ceiling level. By providing, to quote the BBA, a significant additional mechanism for water vapour egress by convection, air permeable membranes can always be used with no additional ventilation, as both air and vapour can move freely throughout the entire roof surface. So essentially, the additional benefits of air permeability mean that no vapour control layer is required at the ceiling level and no openings are required at the ridge. This type of roof construction provides a much more simple and a more robust solution, meaning that there's less likelihood of incorrect ventilation or ceiling specification or issues with installation. As long as the air open underlay is installed correctly, the risk of condensation will be minimal, and that's going to be throughout the whole lifetime of the building. One of the more recent construction membrane developments is the use of external air barrier membranes. Now, this represents quite a significant departure from the accepted traditional practice. However, having a membrane which is highly vapor permeable, but also acting as an external air barrier level, seems to be quite a comprehensive way of achieving the building's airtightness strategy. I spoke earlier about vapour control layers and the placement on the internal side of the insulation. Traditionally, being vapour and airtight, it has performed the function of the airtight layer within a dwelling or building. Whilst the solution does work, it does place a lot of emphasis on the quality of installation and sealing of the internal vapour control layer, which can be difficult, it can be expensive, and it can be very time consuming. By moving the airtight layer to the outside of the heated envelope, and again I mean on the external face of the insulation, it presents a much quicker, a simpler way and a more robust solution, because you're taking the airtight layer away from any surface penetrations, areas where it may be punctured during installation. So again, it seems to be a much better airtightness strategy. Nearly all vapour control layers can be used as the internal air barrier membrane. So that simply means that the membrane which is used internally is both air and vapour tight. On the external side, however, not all vapour permeable membranes are suitable. So for example, an air permeable breather membrane would allow air leakage, which would not help the energy efficiency of the building. What we're seeing now is more mechanically fixed external air barriers. However, there are more advanced membranes today, some which have self-adhered characteristics, which allows for a more continuous external air barrier whilst remaining breathable. When using membranes of this type, it's really important that vapour control is very carefully considered. It might be necessary to limit moisture vapour transfer, for example, using a well-sealed vapour-tight insulation board. The main benefits of an external air barrier comes in the installation process and the robustness that it then adds when it's in situ. So if you have a look at internal air barriers, they require to be sealed around all surface penetration, structural elements, and openings throughout the structure or the wall, which adds considerably to the time and cost of the installation process. Each of these seals represents a potential point of failure for the internal airtight layer. Now, the issue with that is that it may not be discovered until the membrane is covered by internal decorative finishes. And that makes remediation complex and it makes it expensive. But most importantly, failure to meet the designed air leakage rates can have a major effect on the energy performance of the building. So moving the air barrier or airtight layer externally hugely reduces the amount of sealing required, and that increases the likelihood that the air leakage targets will be met. Basically, this allows the use of more ambitious air leakage rates at the design stage, giving improved design flexibility in other areas such as thermal insulation. The effectiveness of these external air barrier systems has now actually been demonstrated on a lot of projects throughout the UK. One example of this is the Anchorage Children's Home, which was built for Hampshire County Council. So achieving a low level of air leakage was an important part of the energy performance strategy for this particular building. And in order to achieve this, what the contractors Raymond Brown did was turned to Wrap-Tight SA, which is an external air barrier which we supply. So what the Raptight SA does is combines very high vapor permeability with low air permeability. And because it's actually self-adhesive, it allows for a quick and simple installation process on or off-site. So although this building looks quite traditional in its outward appearance, it actually uses very high-tech structural insulated panels, or otherwise known as SIPs. So the performance of these panels, along with the 0.5 air changes per hour air leakage rates, provides a very highly efficient envelope, which in turn then delivers very low running costs over the life cycle of the building. So these panels were fully wrapped with the Raptight SA Vapour Permeable membrane, and at the joints, the tape version of this product was used to seal any junctions, openings, services. And what that does is ensures an entirely airtight envelope without leading to any issues, for example, with trapped moisture. So I'd explained earlier the 0.5 air changes per hour air leakage target. When they tested this project, it actually delivered a first time pressure test comfortably of 0.43 air changes per hour. So as I said, sort of comfortably under where they'd set the initial target. More impressively, this air leakage result was achieved prior to installing our ProCheck 500 vapor control layer on the warm side of the insulation. Although the vapor control layer is not necessarily required as part of the air barrier system, they may still be needed to control moisture ingress, dependent on the precise specification of the construction. So we would always recommend an expert hydrothermal assessment be undertaken to verify this. Building regulations compliance in the UK is assessed via the carbon emissions a building produces. So if you take domestic buildings as an example, this is called the dwelling emission rate, commonly known as the DER. So to explain the DER in a little bit more detail, basically it's holistic value which incorporates the effects of all the energy performance measures which are included in the building design. So it allows characteristics, for example, air leakage rates, thermal insulation levels, the areas of glazing, or renewable energy sources like PV panels to be considered within the overall energy performance of that dwelling. So looking at this example here, achieving a 6% improvement in DER means increasing the thickness of insulation from 130 mil to 360 mil, which is going to have a significant effect on the building footprint or the internal space, and that's not even thinking about the cost it's going to incur. In contrast, by improving the air tightness of the dwelling, the insulation thickness can actually remain unaffected. So if you can take the pressure test from 7 down to 1, this results in the same 6% improvement in DER. It's fair to say that with the latest generation of self-adhesive external air barriers, this degree of improvement isn't difficult to achieve. It's going to be highly cost-effective compared to adding over 200 millimeters of extra insulation. So if I can just try to summarize very quickly, and I understand there's been a lot to take in during this webinar. Essentially, there's a ton of differences in the performance characteristics between the different types of membrane. What's important is ensuring the correct membrane specification is used, and that it's being used in the correct position, and that its effect on the whole building envelope is being considered. All of these are very important aspects of the design process. What I'd like to do now is pass over to Ian Fairnton, who's Technical Director here at the Proctor Group. He'll be able to answer any technical questions, queries, or general comments that you may have. Thank you.
Good afternoon, everyone. Hopefully you can all hear me fine. My name's Ian Fairrington. I'm the Technical Director of the Proctor Group. I sit on a number of British standards, including the Control of Condensation and BS 5534, the Code of Practice for Roofing. I know there's quite a lot of information for you to take in, so don't worry. A replay pack will be sent to everyone who registered for the webinar.
We had a few questions submitted by email prior to the webinar starting, and also a very interesting comment about cagoule from Donald, I think, so thank you for that. If anyone does have any questions they want to type, feel free, and you're of course welcome to listen to the existing questions that we have. Alternatively, you can always contact our offices at a later date. We're more than happy to help out. So one of the first questions that we had, Ian, was regarding using use of a membrane behind rain screen cladding, or is it sufficient just to tape the joints with the breathable tape?
Thanks, Kira. Yeah, traditionally it's used a breather membrane within the cavity of the rain screen cladding. However, the introduction of the Vapour Permeable wrap-tight tape has allowed for the taping of the insulation boards, purely just the joints, which has provided a lot of advantages without membranes hanging in the cavity and potential fire risks. Especially over 18 metres, the BRE have done some work with us to assess the fire risk of the wrap-tight tape used in this application over 18 metres with insulation boards, and they have confirmed that they are comfortable with the use of the tape, purely the tape behind the rain screen cladding in this application.
Okay, another question that we had was regarding the use of ventilation with air permeable membranes. And obviously we covered that during the seminar, but there was a question as to how they can prove that no ventilation is required with these types of membranes.
So that question is related to the use of air permeable membranes with enclosed roofs without any ventilation. There's been a considerable amount of work carried out over the recent years with membranes, and a lot of debate regarding whether you need to ventilate these cold pitch roofs or not. There has been a lot of people say that by using a vapour permeable membrane, you don't need to ventilate these roofs. However, it still has some limitations on a vapour permeable membrane, and what seems to have come out of this research is the benefits of air permeability along with vapour permeability. To the extent where even the NHBC now accept that an air permeable, vapour permeable roofing underlay does not require ventilation, but an airtight vapour permeable membrane will still require some ventilation at the ridge, which has lent to a lot of advantages for the house builder being able to completely clad their membrane, the roof with a membrane without any water penetration at the ridge where it's been left. So the roof shield or air permeable membranes in this application has shown considerable advantages in the home building market.
A quick one here, does Wrap-Tight SA stick to blockwork? So the Wrap-Tight SA was obviously the external self-adhesive vapour barrier that I explained earlier in the webinar.
Yeah, that's again another very good question. With any adhesive, the substrate is very important. Whether it be wet or dusty will affect the ability for any adhesive to adhere. With the Wrap-Tight in particular, a primer is not required as long as the surface substrate is clean and dry, and we advise in our installation guide how to achieve that. So yes, it can stick to the masonry very effectively if the conditions are followed.
Jumping to a quick one about software, are you finding much difference in results when using Woofy modelling instead of Glacier?
Yeah, the Glacier method has been very successful for many years, and the Proctor group have been able to provide condensation controlling calculation for a number of years using the Glacier method. However, it does have limitations. It's steady state, only looks at movement in one direction, moisture movement in one direction, doesn't take into consideration driven rain, or indeed absorption or porosity. The Proctor group have invested heavily in the technology of Woofy modelling, where all the technical people can carry out Woofy calculations, which significantly adds to the dynamic nature of the condensation calculation. We can take into consideration the convection, We can put in moisture sources, assuming that there is moisture within the existing building, rather than just assuming it's new build. So it's provided a lot of advantages, and it further emphasises our expertise in this field.
Okay, so a typed question coming through from Clement, who would like it to be explained again whether there are actually effective airtight membranes which are also vapor permeable that can be used in a breathing wall.
Okay, yes, just for clarity, what we're promoting here is a vapor permeable airtight membrane. So what we're providing is a membrane that can be applied to the external envelope that's vapor permeable, so it reduces the condensation risk by allowing the building to breathe, but it provides at the same time an airtight layer. That obviously affects the energy efficiency. So Wraptight would provide that performance that you're looking for there, Clement, in terms of airtight membrane that is vapor permeable, used externally for a consistent seal of the airtight membrane.
Ian, this isn't actually a question, but just on the back of that, can you explain briefly the importance or the requirement for a vapor control layer internally if you're using an external vapor permeable air barrier?
Yeah, another very, very good question, and one that we have lots of debates on, whether you need a vapor control layer with an airtight vapor permeable membrane. The straightforward answer, or less than straightforward answer, is it depends. It depends on a number of factors in terms of the building, wall, fabric build-up. The type of insulation is really important. If you're looking for a breathing wall, you're going to be using an insulation with a high vapor permeability, and therefore there's a higher risk of condensation within that application, and therefore it's more likely that you're going to need a vapor control layer in that type of construction than a vapor tight insulation of low permeability. But as said earlier, we can calculate that using a WIFI calculation for in particular cases.
Okay, here we have a question from Mike. If you use roof shield on the roof, how does this affect air tightness?
Yep, a very logical question there. Roof shield is air permeable, so using a roof shield on the roof increases the air permeability of the loft space. The actual air tightness of the dwelling will depend on the surrounding area of the living space. So for air tightness of a dwelling, we're utilizing a cold roof. The ceiling is really important, and there is many well-sealed ceilings now that are utilized to provide the air tightness of the ceiling as well as the walls, and that is in the living space, and that's the more important place for air tightness when you're utilizing a cold roof. Anything above the insulation, we believe it's more beneficial to be air permeable to reduce the condensation risk, to increase the air circulation within that space, to keep the building moisture proof.
Yeah, so essentially, Mike, if your project was a warm roof, you could use a product such as Wraptight SA or a film laminate product which was airtight to complete that sort of air tightness. Another interesting question from Martin about refurbishment. So when used on an existing listed building with hydroscopic insulation, do you need to allow an air gap below the roof VPM, and do you need to ventilate above if there's slate?
Okay, one of the main applications, or one of the applications that you can utilize roof shields benefits is in the refurbishment market. Because we specifically don't require a vapor control layer at ceiling level, you do not need to have, the refurbishment is not so difficult. a lot of vapor permeable membranes require a vapor control layer to be used at ceiling level, and that is really difficult in refurbishment projects. When you're utilizing roof shield, you don't need that vapor control layer there, so you don't need to have that in place. So you don't need to ventilate the roof with a roof shield roof in refurbishment, even if it's slate, which is reasonably tight, but not tight enough to create a condensation problem in the batten cavity.
Just before we go on to the next question, there's one from Ian. Could you just clarify, Ian, which application and what type of membrane you're talking about in that question? If you could type that, that would be great. Next question from John, asking if we've identified any risks or considerations if the Raptite SA was going to be applied to a building undergoing deep retrofit.
Good question, John. I think probably what we would need to do is probably have a bit more in-depth conversation on what you're requiring in terms of deep retrofit. Obviously, Raptite can be used in refurbishment projects, but it's more used in new build projects. Depending on the building envelope, you can utilize the Raptite SA internally, or indeed if it was an external insulation, you could use it externally prior to putting on the insulation in an external wall system.
Okay, so Ian's asked the question, so regarding internal airtight membrane, ProCheck or Raptite, yellow or red if it's self-adhered actually, so for internal. Which is internal.
Sorry, I'm just trying to. There's two threads of questions there, so I'm just reading through the question. So this is related to a rough concrete floor, sealing the membrane, cables and pipes, and using an internal airtight membrane, like ProCheck. If you're using it internally, then you would be using more of a ProCheck vapor control layer. If it's in a floor, depending on the application, it's going to be difficult to create a complete airtightness in the refurbishment of that. So care would have to be taken at sealing the wall and floor junctions. Now, Raptite has been used successfully in that area for draft proofing on timber floors, and it could be used on concrete floors. So the junction between the wall and the floor would need to be looked at. And if you had a detail of that, then we'd be more than happy to look at that and go into that in a bit more detail.
Okay, just a second question from Clement, and I apologise if I'm pronouncing that wrongly. So you asked about the original question was regarding airtight and vapor permeable membranes sort of being the same thing or being available in that function. And I think you're commenting here, so if an insulation material tolerates changes in moisture content, then that should be fine. Is that correct?
Yeah, I think here, Clement, there. I think you're looking at cellulose fibre, perhaps, and cellulose fibre can be viewed as moisture tolerant, and there has been some very good examples of cellulose fibre used as the insulation, and the potential condensation risk and the potential moisture management that the cellulose fibre provides. So in that case, it might not be as critical to use a vapor control layer because you have a complete breathing insulation that's very effective.
Okay, another question from Donald. So when using a warm roof and roof shield over sarking, do you Oh, recommend. Sorry, I'm not good. I'm not good with the the terminologies. Recommend loose terminating it into the gutter, or do you think we're moving towards creating continuity with some element in the wall construction?
Yeah, Donald. It's obviously tradition to loosely the roofing underlay into the gutter, um, as is usual practice. As dwellings strive for more airtightness, then that connection can be more complicated, and therefore, if airtightness is looked for, we have obviously the wrap tight tape BBA for walls, but we also have wrap tight um, SA used for roofing applications, BBA certification. Now, those two combined together can make the connection at that eaves a lot simpler because you have continuity of the air tightness, in particular where there's a warm roof used. If it's a cold roof, then the detailing of that can be more difficult. Um, but certainly with warm roofs, the connection on continuity of the roofing underlay and the wall underlay is a lot easier.
Okay, so a question from William, who's considering using external insulation on a concrete block structure. So the ideal place, he's saying, for the air barrier would be actually the outside of the block, but would the wrap tight SA limit any moisture flow here?
Yeah, utilizing it, that would again depend on the insulation that's being utilized. If you're using a low permeability insulation, if you're using the wrap tight on the external side of things, of the block work, you get the benefit of water tightness during construction. You get the benefit of a complete airtight membrane or more complete airtight membrane on the outside without as many penetrations. Um, if you were then to put an insulation on the top of that that was of low permeability, then you are inhibiting the benefit of the wrap tight in terms of its breathability. But utilizing the insulation on the outside, the condensation risk would be driven outside the building envelope. And many people in the cladding industry are utilizing the wrap tight on the sheathing board and then applying the insulation on top of that. So here they get two of the three benefits: water tightness, air tightness, but not so much the vapor tightness. But because the insulation's on the outside, the condensation risk is taken outside the building envelope, and therefore a good application.
Okay, here we go. I think this is Ian. Okay, so he's looking for a bit further clarification. Ian Brenington. So if a JPA calculation shows there to be no condensation risk within rain screen wall, so cladding K15, wrap tight SFS, is there a requirement for an internal VCL?
Hi. Yeah, we can do calculations using the JPA software, which is the Glazer method, and it can show that there's no risk of condensation. However, a lot depends on the installation of the various elements there. So the Glazer method, when you put in an insulation board, will assume that it is continuous and well installed. So sometimes you have to look at the outputs from these kind of calculations and see whether they're realistic in an actual site application and a buildability. So we would take a judgment on that and point out to the client whether there was a potential risk if they don't apply all the elements correctly. More than happy that it could be done if it's all installed perfect, but we are in the building industry, and sometimes in the building industry, not everything that goes on the drawing board actually happens on site.
Okay, this is a question about sort of the covering of wrap tight. So obviously wrap tight SA, which Clement's pointed out, it does need to be protected against the elements. and therefore final cover, cladding, etc. Does that limit its use in refurbishment of traditional buildings?
Yeah, yeah. If you're using, if it's an old historic building, then you wouldn't utilise that on the outside of buildings, because you will detract from its traditional look. However, if you are overcladding it in an older building, and want to refurbish the look of the building, then Wrap-Tight's okay. However, you're very correct. Don't use it if you don't want to change the look of the outside in refurbishment.
Thanks, Ian. That's good. So I think that's all the questions we've had. We covered the couple we had before the webinar started. So I just really want to thank Ian for answering the questions. Thank you everyone for coming. I really appreciate the numbers and hope you all enjoyed it and found it helpful or educational. We are here. We do have a technical team who can take questions. Ian's got a team of 5 or 6 which can do drawings, calculations, answer any questions over the phone. And so you'll find the details on our website. We will be sending this back out so that you could circulate it to colleagues or potentially, look back at areas of it that you actually interested you. And sorry, just one last question coming from Clement again. In this case, it can be used internally instead. That's a good question.
Okay. Yep. Yeah, that's a good point, Clement. You can use it internally instead. Again, depending on the building fabric. But in that refurbishment case where you don't want to change or compromise the look of the building aesthetically in traditional buildings, then yeah, you can turn to the inside and look to see increase the air tightness from the inside, utilising the benefits of the Wrap-Tight.
Okay, I've already done the thank yous. Final thank you to Kenny, who's in our marketing team sitting next to me very silently, who's put all this webinar together. So as explained, please contact us and we'll probably do another webinar in the new year, which hopefully you can make. And thank you all for your time.